Good afternoon, class. What we'll be talking about today is we'll talk about today's technology, focusing on the differences and similarity between analog system and digital system. Also, we'll talk about some advantages and disadvantages. So, to start off, I know that we are now in the I would say in the digital age, but let's go ahead before we can show these differences and similarity by making a definition or giving a definition for analog system. Analog electronic system, let's say like an audio and video and so on, is the process of taking an audio or video signal and translate it into electronic pulses. We can say that analog electronic system is represented by a continuous variable signals. Alright, continuous variable signal. And so we need to give some example and demonstrate and show what we mean by continuous. As in, for example, let's say the sine wave. Or for example, this clock here, the hand goes around on the face here, and where the hand is at any particular time is the time of the day. So let's go ahead and look at, in the first case here on this board here, I have what you call a rectifier circuit. We know that in today's technology, a lot of application, electronic application use that DC, direct current, but we have readily available supply of alternating current. So there is need to convert the alternating current to direct current so that a lot of these applications could use it. What I have here is a rectifier circuit. It rectifies this current here. And the input, if you look here, we have a diode here. This diode actually allows current to flow in one direction. We have a resistor here across this AC source. So this input here that goes in, you can see it's like a sine wave. It goes in here, and what happened is that this rectifier cuts this voltage in half, and it results in a pulsating DC power. So now, if you look here, I have here a measure of this pulsating DC output. You can see that it's also continuous. So this is a representation of analog signal. Now let's look at another one here to make it a little bit more clear. Below this rectifier circuit, I have another circuit we call a positive unbiased clamp circuit. Alright? Now, what this does is that it raises this positive peak, or it holds the voltage to a specified level. The clamp raises the positive peak. If you look here at the input, which is also alternating, it's like a sine wave. And in this circuit here, we have a diode and we have a capacitor. Alright, this capacitor has a capacity to hold current, and this diode here, remember it conducts from this end here going to the other way, the other side, cathode to the anode. The amount that goes in here, and this is the amount that comes out, You see that everything here, the sine wave here, the bottom part here has been trimmed off. Everything is on the top here. So I have here an input representation down here and an output here. Let's say, for example, if putting 10 volts of current here, what happened here is that in the negative cycle of this input AC signal, the diode here is forward bias, and it conducts, charging this capacitor to its peak positive value. So then, of the voltage in. So during the positive cycle, the diode is now reversed bias, and it does not conduct. So the voltage now that comes out is equal to the voltage in plus the amount in the capacitor here, which gives you 2 times the amount you put in. The amount out is 2 times the amount in, and that is represented here. Okay, this positive unbiased clamp circuit, what it does, it offsets the input signal so that all of the waveform is above zero. All is above zero here. Alright? So the voltage out is equal to 2 times the voltage in. For example, if we put 10 volt in, then voltage out is 2 times 10. 10 would be 20 volt. That's just an example. But by the way, the main important thing here is to show that this here, the data in and data out, it's of continuous form. It's not discrete or discontinuous, but it's continuous. So this here is analog representation. Now, before we go further, we need to bring in digital system. So what is, we need to also give a definition for the digital system. We can say the digital signal are discrete values or discontinuous. Like it's prevalent like in computers and so on, where you have characters, numbers and letters are stored as bits of information. And these information stores as 0 and 1. The bit of data are arranged into bytes, which is a line, or which would be lines of zeros and 1. So we need to also give some diagram of these type of data or of signal. So if you look here, I have a digital clock, and this reading on this clock here, 8:10. It's digital. It's on the digital clock, and we have a representation here. This bar graph shows digital signal representation, and as I was talking about these bits of data, if you look on this side here in this little table, we have some minutes on one side of the table, and we have the binary representation of those minutes on this side, right hand side. So 1 is this. 10 minutes would be represented by this string of 0, 1, 1, 0, 1, 0. 30 minutes would be represented by 1, 1, 1, 1, 0. So these are the binary representation of those minutes. Alright, now we don't want to confuse this here with what we'll be talking later on. We'll be talking about some logic gates, which is represented also by binary data of 0 and 1, where 1 represents a switch that is on and 0 represents a switch that is off. We call that the Boolean logic or logic gates. Alright, so we'll talk about so translation of information in this digital system is in binary format, such as logic gate. The signal takes 2 forms represented by an on switch, which is indicated by 1, and an off switch indicated by 0. Alright, we call that Boolean logic. So using these logic here, we have some important gates. We call them the logic gate. One of them is the OR gate. Alright? And in this OR gate, we have two inputs, A and B. You can name it how you want, but let's say we call them A and B. And if you look here, we have these two switches A and B. They are parallel here. We have a battery here that supply current, and we have a light bulb here. So if either one of these two input here, A or B, is closed, current would flow through, and you will get A plus B, which is the output of this OR gate, would be on. The only time it will be off is when both the A and B are open and no current flow. Then A plus B would not conduct, and this lamp here would not light. Otherwise, in these three situations below here, this light bulb here would light. This is what you call the OR gate. Alright? Now we have another gate here we call the AND gate. With this AND gate, we have two inputs, same thing like A, like previously A and B, but we have the output. We call them not as plus, but like multiplying them. It's AND. And for current to go through, these two switches are in series here, as opposed to above where they were like parallel. Here they are in series, and here we have the battery, and here you have the lamp. So now the only time these two switches will conduct and A times B would be on is when both the A and the B are closed and current comes through. Otherwise, on the other three such states, you would not have A times B conducting any electric current here, any electricity. It would be off. So this is what we call the AND gate. Alright? Now, apart from the OR and the AND gate, we have another important one we call the inverter, which is this one here. This inverter is that what it does is like if A is on, the switch is on, it inverts it, so it doesn't light. If A is off, then it inverts it to give you the opposite plate. And we have a little table of it here. When A is 1, the other one is off. Now with these two gates, the OR and the AND, and the inverter, we'll use those three to make two new gates. We call them the NOR gate and the NAND gate. And the NAND gate. So those are two important gates we'll be making using the OR and the AND gate along with the inverter. So for the NOR gate, if you take the OR gate and you put the NOR gate here, lined up with the OR gate, the NOT gate, sorry, the NOT, this is the inverter, this is the inverter here, we get the NOR gate. So what this does, this NOR gate here, the output, it inverts the OR gate. If the OR is on, it turns it off. If it's off, it turns it on. Now, if you look at the NAND gate, what the NAND gate does, since you line up the AND gate with the NOT gate, whenever the AND gate is on, the NAND gate, it turns it off. So the NAND gate turns it off because the AND gate here, in these three states here, it's off, it turns it on. The last one, it turns it off. Now, this here is what we call the digital system. We have here a clock which is also digital. This is an example of it. This is an example of digital clock. So like if you press here, you see these data here. This here is this data here is a digital display of 301. Alright? This here is a digital clock. Okay. Now, we need to talk about some differences, some advantages and disadvantages of the digital system and the analog system. So if you look at the digital and look at some advantages, we can say it is more durable. All right, it gives better resolution because it's improving as time goes on. We can say the digital is compressed and it moves, it stores, it transmits more data. Digital is more compressed and transmit more data over the same spectrum. All right, you can see that. Digital signal can be transmitted without degradation due to noise. So digital signal can be transmitted without degradation due to noise. Some advantages for the analog, we can say analog signal of you have analog signal are of higher density than the digital, and the analog has the potential for an infinite amount of signal resolution. Those are some advantages of the analog. Of course, there are disadvantages for the analog due to the effect of random noise, which can cause loss of signal or signal loss, low impedance. Those are some disadvantages of the analog, and so on. But you know, in today's electronic world, we have integrated circuit. You know, where a lot of the system use both digital and analog integrated system. So we'll talk more about digital and analog later on. So we'll leave it as it is here now, but I think we were able to differentiate between the two, showing the different types of data. Thank you.